Hello my friend, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting cubic equation t cubed plus t squared equal to 36. We need to solve this equation for t. So if you have your answer, you can also solve this question with me right now, and then we will check our solution, so it will be really interesting. So first of all, let's write the 36 on the left side. So this is our first step. This is my approach, and of course I want to show you this one. So t cubed plus t squared and minus 36 is equal to 0. So this is our first step, minus 36 equal to 0. Right now, of course, there are a lot of ways how can we solve this equation, but I'm going to show you this one. So right here on the left side, we have t cubed plus t squared. Okay, so we have a cube and square. We have a sum of a cube and a square. But right now, let's try to express this 36. Of course, there are a lot of ways how can we express this. A lot of students might be thinking, okay, 36, let's express it, for example, 18 plus 18. This is the first way. Of course, this is a correct way how can we express it. But the better way for us is to express it as 27 plus 9. And a lot of students might be asking, why do we choose this expression? Of course, because of that, 27 can be written as 3 cubed, and 9 can be written as 3 square. Okay, so we can express it as a cube plus a square. So then we can group cubes and a square. So let's do this. Let's do this approach, and let's try to solve this question in this way. So we have t cubed plus t squared, and as I said before, instead of 36, we're gonna plug in this one, 27 plus 9. Let's do this step by step. So 27 plus 9. Right now we can actually get rid of the parentheses, but we need to change all the signs to the opposite one. So we need to change this sign to the negative because we have a negative before parentheses, yeah? So we have t cubed plus t squared minus 27 and minus 9 equal to 0. Okay, this is our question right now. And as I said before, instead of 27, we're gonna choose this option, 3 cubed, and instead of 9, we write 3 square. So we have t cubed plus t squared minus 3 cubed and minus 3 square. So I really hope you understand. Of course, we can easily write it only in one line, but maybe a lot of students here, so I just want to solve this step by step. Instead of 36, we write 27 plus 9. Instead of 27 plus 9, we write 3 cubed minus 3 square. Okay, right now, as I said before, we're going to group. So we have t cubed and we have 3 cubed. We have t square and we have 3 square. So right now, let's group our cubes and our squares. So what do we have as a result? We have t cubed minus 3 cubed, so t cubed minus 3 cubed. And in another parenthesis, we have t square minus 3 square, so t square minus 3 square equal to 0. Really great. And right now, let's look at this question from a different perspective, from a different angle. What do we have right here in this parenthesis? Difference of cubes. What do we have right here? Difference of squares. So we need to know, we need to remember, we need to learn our classic school formula. For example, the first one, difference of cubes. A cubed minus b cubed equal to, what do we have? A minus b, and in another parenthesis, we have a square plus ab plus b square. Okay, this is our formula, difference of cubes. What about the next formula? A square minus b square. What do we have right here? A square. We have a square minus b square. This is our old-known formula. A lot of students know this formula. This is equal to a minus b, a plus b. So this is the most popular formula, a minus b, a plus b. Really great. And right now, let's apply this. Let's expand it in terms of this formula, difference of cubes right here and difference of squares right here. So let's do this. Let's start on the left side. What do we have as a result? T minus 3. I just do this formula real quick. T minus 3. And in another parenthesis, we have t squared plus 3t and plus 9. Plus, what do we have in another parenthesis? T minus 3 and t plus 3. Okay, so we expand this expression in terms of formula that I wrote before. So difference of cubes, difference of squares. But right now, let's look at this question from a different angle. What do we have right here? We have a lot of parentheses, but the main thing, we have the common parenthesis t minus 3 right here and t minus 3 right here. So we can actually factor it as a common. So let's do it right now. Let's factor this t minus 3 as a common expression. Let's do it. So t minus 3, this is our first parenthesis, and in another parenthesis, what do we have? I just want to change this to another brackets, and as a result, what do we have? This expression from this part, yeah, we have t square plus 3t and plus 9, yeah, and we have plus this, so we need to write this one, plus t plus 3, t plus 3 equal to 0. Really great. What are we going to do next? The next we're going to simplify this expression right here, because we have we can actually get rid of this parenthesis because we have all the time addition, so we can actually add it real quick without any problems. So we have t minus 3, and in another parenthesis, what do we have? We have t square, and we don't have any square, so we have only t square. 3t plus 4t, yeah, we have plus 4t, and plus 9 plus 3, so we have plus 12, yeah, so plus 12, okay, plus 12 equal to 0. Really great. And right now we can actually say, okay, we can solve it real quick because we have two parentheses and a product of two parentheses equal to 0 when the first parenthesis equal to 0. So we just write it as a two branches. So t minus 3 equal to 0. This is our first branch. And another branch, t square plus 4t plus 12. So we have t square plus 4t and plus 12 is equal to 0. Okay, really great. And what are we going to do next? Of course, we have a product of two parentheses, and we can solve this question for this part real quick without any problems, because t minus 3 equal to 0, so t first is equal to 3. This is our first answer, first root. This is our one real number root, and we find it. Right now, let's solve another branch. This part, this is our quadratic equation, and of course, this is up to you. There are a lot of ways to solve this quadratic equation. I prefer the basic and a classic method with method of coefficients. So everyone knows about it. So a equal to 1 from here, b equal to 4, and c equal to 12. And let's start with discriminant. So d equal to b squared minus 4ac equal to b squared. So we have 4 squared minus 4 times a times 1 times c times 12. As a result, 4 squared we have 16 minus 4 times 1 times 12 we have 48. And our discriminant is equal to minus 32. So our discriminant is less than 0. And a lot of students might be saying, okay, right here we don't have roots. This is correct, but not fully correct, because we don't have right here real number roots. We have two. From here we have two complex roots. Really great. Two complex roots. And what are we going to do next? Of course, let's solve it. Let's find it. So t second and t third. So t second and third equal to minus b, our all-known formula, plus minus square root of discriminant and all over 2a equal to. So we have minus b minus 4 plus minus square root of discriminant square root of minus 32 and all over 2a, 2 times 1. Okay, and of course this is our root, but we can simplify this a little bit. First of all, this minus 32, we can actually simplify this because, not like simplify, we can express it in another way, because we can find square root, we can apply this square root property, we can split it. So right now let's express this minus 32 as, right here, minus 4. This minus 32 we can express as minus 1 times 16 and times 2. Yeah, we can easily express it like that. Of course, we can express the 8 times 4, something like that, but I prefer this expression, all over 2. Right now, let's remember a really interesting property, a really great property. When we have square root of a times b, of course, and maybe times c sometimes, three variables, we can express it as square root of a times square root of b and times square root of c. And right now let's split it, because we have three values right here. Let's split it like that. What do we have? We have minus 4 plus minus square root of minus 1 times square root of 16 and times square root of 2 and all over 2. Okay, square root of 16 equal to 4. This is our imaginary unit, square root of minus 1 equal to I, and as a result, in general, we will have minus 4 plus minus 4i square root of 2 over 2. Okay, and the final step, a lot of students doesn't see it because right here we can actually divide all of these coefficients by 2. We can split it like that. We can write minus 4 over 2 plus minus 4i square root of 2 over 2 equal to. As a result, minus 4 over 2 equal to minus 2 plus minus. Right here we can actually simplify this one. So we have 2i square root of 2. 2i square root of 2. So these are our complex root. Of course, this is our real part, this is our imaginary part if you're interested in this, but basically we solve this question completely and step by step. So let's write our final answer to this question. So our answer. So t first equal to 3, t first equal to 3, t second equal to minus 2 plus 2i square root of 2. Yeah, 2i square root of 2, and our t3 equal to minus 2 minus 2i square root of 2. So these are our roots to this question. These two roots are our complex root. This one is real number root, and this is our full answer, full solution to this question. And a lot of students may be asking, maybe we have like more roots right here, maybe we have like the fourth root, the fifth root. I'm going to give you one really important hint, a really important prompt to you. Maybe this is very helpful. This will be really helpful for a student, because sometimes, for example, you have like equation. Let's write, for example, x to the power 5, something like that, plus x to the power, for example, 2 equal to 1, something like that. Yeah, we don't need to write exactly our equation. I just want to write something like a little bit complicated. X to the power 5 plus x squared equal to 1. And I'm going to give you one really important hint. This hint is called like a fundamental theorem of algebra. Extremely helpful theorem, which helps you to instantly guess how many roots you will have, okay? Like if in a few seconds. How does it works? You have an equation and you scan what is the highest power. Right here 5, right here 2. Of course the highest power is 5. So we will have from here 5 roots in total. Okay, 5 roots in total. You don't know how many real number roots, how many complex roots. Of course you can easily have right here 2 real, 3 complex, 3 real, 2 complex, or something like that. But it helps you to actually to eliminate a wrong thoughts, wrong ideas. Maybe I have like a 6th root, 5th root. 5 power is the highest one, so 5 roots in total. And exactly in our question we have, I just want to rewrite it because right now we're gonna check our t equal to 3. So in the beginning we had t cubed plus t squared equal to 36. And of course you can actually, right now we can actually apply the theorem t cubed plus t squared equal to 36. How many roots do we have in this question? Of course 3 roots in total. We don't know how many real number roots, how many complex. Of course right now we do know because we solved it. But in general 3 roots in total. For example, you start solving this question, you have, okay, 3, so it means 3 roots in total. And of course, if you solve this question with 1 real number root, maybe something goes wrong because you forget about this part. And it's extremely tricky moment because, you know, t cubed plus t squared equal to 36. A lot of students might be thinking maybe t equal to 1 is a correct root, maybe t equal to 2 is a correct root, and then they try to solve this question by inspection. They say, okay, 3 is a correct root. They say, okay, 3 cubed plus 3 squared equal to 36. Okay, and they say, okay, 3 is the correct answer, and they solve this question with the 3 lines. It's extremely wrong because we even with the fundamental theorem of algebra we have 3 roots. Okay, if you, for example, start solving this question, we have 3 roots in total. So it's really weird to solve this question with 1 real number root. You solved it with the inspection method. Okay, so every time you solve this type of equation, it's also really great for you and for your teacher to write, for example, according to a fundamental theorem of algebra, we have 3 roots in total to start with it. The next step, of course, factoring, because if you solve this question like that, you forget about complex root. A lot of thoughts, and it's also really great for you to know all of the things because it's extremely important. And to be honest, in conclusion, I'm going to say this is not the hard question. Don't be scared about it. All you need to know, this is the 2 formulas, or all you need, because right here we group something, we apply these formulas, and then we solve 2 branches. The first one is linear function, this is a quadratic function, but to be honest, discriminant and this expression, you cannot be scared about it because, yeah, this is not that hard. And my quick recommendation, if you still have any question, if you don't know how can we solve this question, of course you can easily pause the video and go for a walk real quick and then go back home and try to solve this question once more. You don't need to watch this video one more, and of course if you solve this question you can easily watch this video once more and to try to follow what went wrong. Yeah, something like that. Of course practice is the key to learn math. If you practice, everything will be great. And to be honest, this is not the hard question, so I think everyone, even teachers, can easily practice it, remember something, and of course learn something new, because this is really great. And of course, as I said before, practice is the key to learn everything, not exactly math, but everything. Yeah. So thank you everyone for your time. Take care of yourself. Have a great day. Also, thank you genuinely thank you for watching this video. I try to make videos every day, and of course I really appreciate your support, that you watched this video. I posted like more than like 600 videos, so I really appreciate that you're with me. We have this community with the teachers, students, people all over the world with the different countries. I have all people from different continents, and it's also really great that we learn math, that we study here, and also want to say thank you for that. It's extremely important, and these days it's extremely important to be together and to do all the best for your neighbor, for your family, and for everyone. Yeah, this is my few words to everyone. Yeah, so thank you for your time. Have a great day. Take care of yourself. Also write the thoughts, your response in the comments below. See you in the next videos, and take care of yourself.